Alright, a block weighing 300 newtons is moved at a constant speed over a horizontal surface by a force of 50 newtons. First thing we want to do is draw a force diagram or a free body diagram. I'm going to start with the dot. Going down, we have the force of gravity. Going up, we have the normal force. Since this is a block going over a horizontal surface, it's not going up or down, accelerating up or down. Our force of gravity is equal to our normal force. We move on. It says one of the first things is a block weighing. When it says weighing, that means the block weighs and has a weight of 300 newtons. So if you want to say W is equal to 300 newtons, that is okay. But to be more accurate, weight is a force, and that force is the force of gravity. So Fg is equal to 300 newtons. If that's equal to the normal force, our normal force is also equal to 300 newtons. We keep on reading. Moved at a constant speed. Constant speed is a key word. If there is a constant speed, that means our left and right forces are equal if it is moving left or right. If the direction of motion is left or right and it's moving at a constant speed means forces are balanced. Okay, keep on reading. Constant speed over a horizontal surface by a force of 50 newtons. So force of 50 newtons applied parallel to the surface. That probably means that FAPP will be equal to 50 newtons. What does the constant speed tell you about the forces acting on the block? We just answered that. Constant speed means the forces are balanced. FAPP is equal to 50 newtons. The opposite force of friction, FF, is also equal to 50 newtons. So right here we have a free body diagram that is completely filled out. We're going to keep on moving. B, what is the coefficient of friction? Our coefficient of friction, the equation is mu is equal to FF over Fn. If that's the case, FF is equal to 50 newtons. Fn is equal to 300 newtons. When you divide those two numbers, 50 divided by 300, you get 0.166, and it repeats and repeats. So we are just going to estimate that as 0.16. If you want to do significant figures, that can round to 0.2 if you like. That's part B. Part C asks, what is the mass of the block? C asks, what is the mass of the block? We know if mass is question mark, if you look at your equation sheet and see all of the equations that have mass on it, one of the most appropriate ones would be F of G is equal to m times G. The force of gravity, which we have as a given, we know the acceleration due to gravity is estimated to be 10 meters per second squared. So if we're looking for mass, we'll have to isolate m to get m is equal to Fg over G. In that case, we get 300 newtons divided by 10 meters per second squared. You get 30 kg. That's our answer for C, 30 kg. For D, what is the acceleration of the block if the coefficient of friction were to be mu is equal to 0.2? If mu is equal to 0.2, we know that our normal force is still 300 newtons. But since the coefficient of friction changes, that means our force of friction will change. If our force of friction will change, we have to use the equation to calculate that. Force of friction is equal to mu times the normal force, which equals 0.2 times 300 newtons. If given that, we have a 0.2 times 300 is 60 newtons, and then we change in our free body diagram 50 newtons to 60 newtons. Now we have an unbalanced force. That unbalanced force moves the friction force to be more than the force applied. So our F net is now minus 60 from the force of friction plus 50 from the force applied to give us minus 10 newtons. The question D asks what would the acceleration be? We know the equation for acceleration is A equals the net force divided by the mass. So we get net force of minus 10 newtons divided by a mass of, what we have, 30 kilograms. We get negative 0.333, repeating, meters per second squared. Round that, you get 0.3, negative 0.3 meters per second squared as our answer.